Okay, 2.5. 2.5 is all about starting with word problems and changing them into algebraic expressions. So for example, I'm just going to go through a few problems that were on that 2.5 group practice sheet. Let's do the Twitter followers one. Twitter followers. It was problem number 1 under group practice on the back side of the 2.5 sheet. And it said, this girl named Josephanna, she had X Twitter followers. She started with X. She started with X Twitter followers. And this year she doubled her followers. So last year she had X. And then this year she doubled her followers. Another way to say the word doubled would be twice. Maybe now she has twice X. These are all words we've heard used before when we talk about changing math into English. So she started with X Twitter followers and then she doubled it. In other words, she has twice that now. When we said twice before, we said twice is the same thing as 2 of something. So you started with X and now you have 2 X's. X times 2, or 2 times X, would be how you describe this relationship. She started with X Twitter followers and she doubled it. So she started with X and now she has 2X. Okay, and that's all they're looking for in that problem, is for you to change it to something algebraic. Let's do a different example. How about number 4? Katie is saving money for a new iPad. She has an unknown amount of money in her savings. Anytime we see that phrase, unknown number, unknown amount, we know that's going to be our variable, because a variable is that unknown number. So let's call that X, alright? X is now the amount of savings, or amount of money, that she has in her savings, okay? X is the amount of money. Now, it says her dad doubled that amount. So she started with X and then her dad doubled it. We know from the problem we just did, if you start with X and you double it, the way you express that is now you have 2X, 2 times X. X has been doubled from here to here. Alright? Her dad has doubled her savings. The last thing it says, but she spent $50 of it. So she had X, her dad doubled it, and now she spends 50. So from that amount, we're going to take away $50. Now, how does this work? Let's say X equals, let's say X equals $100, alright? If X equals 100, we know up here, X equals the amount of money in her savings, okay? So if X equals 100, here's how we would evaluate it. We'd plug it in. 2 times 100 minus 50. Order of operations, let's do 2 times 100 first. That gives us 200. And then we do our subtraction. That equals a total of 150. So again, she started with X. Her dad doubled it. She's at 2X. She took away 50. That's our algebraic expression. And then for an example, I plugged in an X value to evaluate it. Let's say X was 100. We plug it in. We get 200 minus $50. Now she has $150 left. Alright, let's do one last one. Let's do one from the independent work for 2.5. Let's do this pizza one. A pizza from Pizza Hut costs $9 for the pie. Alright, so anytime you buy a pizza, you know it's going to be a minimum of $9 for the pie itself. Now, that's a pie with no toppings, right? Because the next thing it says is it costs an extra $1.5 or $1.50 for each topping. Anytime you see each of something, that means every one topping. So $1.50 for each topping means it's $1.50 for one topping. And they want us to write an expression to show how much a pizza would cost if you order T toppings. So T is our variable, capital T. Variables can be capital or lowercase. T is our variable. Now, how would this expression look? We got to make an expression so that we can plug in any number for the number of toppings we order and get how much our total cost would be. So let's think about it. Regardless of how many toppings we get, we know we're going to have to pay that base $9 for the pie. So we're going to start at 9. That'll be the first one. Now, with each topping we order, we're going to be adding money on to the total price. We're going to start at 9, and as we order more toppings, it's going to get more and more. So we know we're going to put a plus here because our price is going to keep going up and up. And $1.50 for one topping, but we're getting T toppings. So if one topping is $1.50, two toppings then would just be 2 times $1.50. So one topping is $1.50, then two toppings would be $3. 3 toppings would be $4.50. 5 toppings would be $6. So in other words, if T is our number of toppings, to get our cost for that, all we have to do is multiply T times $1.50. So our expression would be 9 plus $1.50 times T.